Good day everyone. Today we'll discuss false position method. False position method, also called the linear interpolation method, is another well-known bracketing method. It is very similar to bisection with the exception that it uses a different strategy to come up with its new root estimate. Rather than bisecting the interval, it locates the root by joining f of x sub L and f of x sub u with a straight line, as shown in this figure. The intersection of this line with the x-axis represents an improved estimate of the root. Thus, the shape of the function influences the new root estimate. Using similar triangles, as in figure 2.2, the intersection of the straight line with the x-axis can be estimated as this equation 2.5, we have f of x sub L divided by x sub r minus x sub L is equal to f of x sub u divided by x sub r minus x sub u, which now can be solved for x sub r is equal to x sub u minus f of x sub u times the quantity x sub L minus x sub u divided by f of x sub L minus f of x sub u. This is now the false position formula. The value of x sub r is computed with equation 2.6, then replaces whichever of the two initial guesses, x sub L or x sub u, yields a function value with the same sign as f of x sub r. In this way, the values of x sub L and x sub u always bracket the true root. The process is repeated until the root is estimated adequately. The algorithm is identical to the one for bisection, with the exception that equation 2.6 is used for step 2. Example, use false position method to obtain a root from the function f of x is equal to x cubed plus 4x squared minus 10. Terminate the process if the absolute approximate error is less than or equal to 0.0001 and tabulate the results. For the solution, we assume that x sub L is 1 and x sub u is 2. These are the initial values. And as evaluated on the earlier example on bisection method, we found that f of x sub L is equal to negative 5 and f of x sub u is equal to 14. And then as you can see again, the function changes sign between values of 1 and 2. So we can use x sub L is equal to 1 and x sub u is equal to 2 as initial guesses. Going on to the first iteration, we use now x sub L is equal to 1 and x sub u is equal to 2, with f of x sub L is equal to negative 5 and f of x sub u is equal to 14. And then solving now for x sub r, that's equal to 2 minus 14 times 2 minus 1 divided by 14 minus negative 5. This is now equal to 1.2632. And then solving now for f of x sub r, that's equal to 1.2632 cubed plus 4 times 1.2632 squared minus 10, that's equal to negative 1.6016. And then evaluating for the product of f of x sub L and f of x sub r is equal to negative 5 times negative 1.6016. That's now greater than 0. Therefore, set x sub L is equal to x sub r, that is 1.2632. And then going on, we're going to solve now for the second iteration. We'll now use the values x sub L, that is 1.2632, and x sub u is equal to 2. And then f of x sub L is equal to negative 1.6016 and f of x sub u is equal to 14. And then solving now for x sub r, that is 2 minus 14 times the quantity 2 minus 1.2632 divided by 14 minus negative 1.6016. This is now equal to 1.3388. And then solving for the absolute approximate error, since we have now a previous approximation, that is the absolute value of 1.3388 minus 1.2632, that's equal to 0.076. Then f of x sub r is now equal to 1.3388 cubed plus 4 times 1.3388 squared minus 10, that's equal to negative 0.4308. And then the product of f of x sub l and f of x sub r is equal to negative 1.6016 times negative 0.4308. This is greater than 0. Therefore, we set x sub l is equal to x sub r, which is 1.3388. Continuing on, since absolute approximate error is 0.0756, we're now going to the third iteration. We will now be using the values x sub l is equal to 1.3388 and x sub u is equal to 2. And then f of x sub l is equal to negative 0.4308 and f of x sub u is equal to 14. And then solving now for x sub r, that's equal to 2 minus 14 times 2 minus 1.3388 divided by 14 minus negative 0.4308. This is now equal to 1.3585. And then solving for the absolute approximate error, this is equal to the absolute value of 1.3585 minus the previous approximate. We have 1.3388, that is now equal to 0.0197. And then f of x sub r is now 1.3585 cubed plus 4 times 1.3585 squared minus 10. This is equal to negative 0.1108. The product of f of x sub l and f of x sub r is equal to negative 0.4308 times negative 0.1108. This is greater than 0. Therefore, we set x sub l is equal to x sub r, which is 1.3585. Continuing on with the iterations, since your absolute approximate error for third iteration is equal to 0.0197, we still need to continue the iterations. We need to terminate the process at an absolute approximate error of less than or equal to 0.0001. After 7 iterations, we found the root to be 1.3652 and it is now terminated at 7 iterations since the absolute approximate error is now equal to 0.0001. That ends our lesson on false position method. Thank you.